know how this is possible, but our answer to this one is wrong. Graded wrong. I explained it to a few people wrong. Apparently, we all had a mental breakdown at the same time. Or maybe everybody knows it's wrong and everybody's just sort of laughing at me behind my back. I don't know. But let's look at it again. This is another speaker face-off. So speakers playing 500 hertz sound, 6 meters apart. How many points of constructive interference are there between them? So you know this is 6 meters. You're clearly going to need the wavelength. So let's get the wavelength real quick. That was right. 343 meters per second equals 500 times the lambda. So lambda is 0.686 meters. Yeah, 0.686 meters. That was correct. So the way you would do it is you'd say, well, we've got to think about the difference in path for constructive interference. Right? The difference in the path, we're going to go all the way to the formal expression. It's the difference in path, delta x over lambda times 2 pi, plus the difference in the phase constant. And you want that to be equal to 0 for constructive, or 2 pi for constructive, or 4 pi for constructive. So let's see, they're in phase, so this is 0. There's no difference in their phase constant. And this is delta x, is what's the difference in the distance from the speaker to the point. So the best way to do this isn't to try to use a formula, but just to think it through. One place you know there's going to be constructive interference is right in the center. Because right in the center, x1 is 3, x2 is 3, if you want to call them x1 and x2. x1 minus x2, or 3 minus 3 is going to be 0. So you definitely have one in the center. And then you want to think how many are going to happen over here, and how many are going to happen over here. Okay, so at the center, it would be 3 minus 3 over lambda times 2 pi. But that's equal to 0, so that's that case. Okay. So as you move, let's say left, how far to hit another one? And this is where we went wrong. As we said, well, in interference, you always move a wave. You move one lambda, you get to the next one. You move another lambda, you get to the next one. That's when you're moving one speaker, or something is making you shift by one wave. But here, when you move, say, x, you're moving a distance x from speaker 1 and a distance x from speaker 2. So it's a case where you get sort of a 2x effect. Okay, so it's not that you have to move a wave, it's you have to move a half wave. That's where I made the mistake. For some reason, I said you had to move a wave. I don't know how I made that mistake. If you go to the first speaker face-off, we had it right. Then we said, how far do you have to go from the interference constructive to destructive? Well, then you have to move a half wave to get from constructive to destructive, but since the effect is doubled, the answer there was a quarter of the wavelength. Now we're saying the distance between constructive, those are half wave apart. So really what we need to do now is take, so on the left, we just say 3 meters. How many half waves can you fit into 3 meters? 3 meters over 0.686, but half of that is 343, and that comes out to 8 point something. So this gives you 8 times. It happens. Okay. And then on the right, 8 times. Also, because yeah, this comes out, or does it come out to 9? No, 8 points. Yeah. So 8 on the left, 8 on the right, and 1 in the middle, 17 is the real answer. Just forgot a factor of 2. The whole department forgot a factor